Okay, so welcome to our class. What we have here is trigonometry under further mathematics. Question says if this equals to this, so you should prove that tan 15 is equals to this. How do we achieve this result? First of all, our cos 60 degrees here is a special angle, and the value is 1/2. In fact, we have three basic special angles: 30, 45, and 60. So let's express cos 60 in terms of special angle. To do so, solution to the question. So we have 2 tan 15 degrees over 1 plus tan 15 degrees 60. And cos 60 is something as 1, and the value is half. So from here I can cross multiply. I have 1 into 1 plus tan square 15, 2 into 2 tan 15 in degrees. So if I open the bracket, 1 times 1, that will give me 1 plus 1 times tan square 15 degrees, I will have tan square 15 degrees. 2 times 2 will give us 4 tan 15 degrees. So since we have tan 15 on both sides, let's represent it as something, any variables of our choice. Let tan 15 equals to m. That is, when you are seeing tan 15, I will put m. So here becomes 1 plus m squared. Here is tan square 15 degrees. That's why I'm taking here as squared. Here is now 4m. So if I rearrange this, I can write this as m squared plus 1 equals to 4m. Since we have square and a variable without square, invariably it's leading us to a quadratic expression. So it'll give us m squared minus 4m plus 1 equals to 0. So what we have is a quadratic expression, although we can't factorize this. To factorize means we have two numbers. If we multiply the two numbers, we have positive 1. If we add the same two numbers, we have negative 4. There's no factor of such. Since we cannot factorize, let's apply the formula method by equating what we have to the original expression of a quadratic equation that says c is equals to 0. So all I need to do is to compare each variable. The coefficient of m squared here is 1, even though we are not writing it. So my a, if I compare these two, my a is 1, my b is minus 4, my c is positive 1. 1, my b is minus 4, my c is 1. So what does the formula state? It says m equals to minus b plus minus b squared minus 4ac over 2a. So let's fit in the constant into the expression. My m becomes minus into minus 4 plus minus b again, which is minus 4. That becomes minus 4 squared minus 4 times my a is 1, my c is 1 over 2 times 1, a is 1. So if I simplify this, minus minus, I will just have positive 4 plus minus 4 squared is 16. So anytime you are squaring a negative value, make sure you put it in brackets. Minus 4 times 1 is minus 4 times 1 is also minus 4 over 2 times 1 is 2. So if I simplify what I have 4 plus minus 16 minus 4 is 12 over 2. 12 is a rational number that is solved. I will express this as a perfect and imperfect squared. So my m becomes 4 plus minus, which is 4 times 3. 4 is a perfect square, 3 is not a perfect square, over 2. M becomes 4 plus minus. Square root of 4 is 2. Here will give us 2 root 3 over 2. So what is common from the numerator? We have 2 as a common factor. If I remove 2 from here as a factor, I'm left with 2 plus minus. If I remove 2 from here, I'm just left with root 3 over 2. So these 2 can cancel these 2. I'm left with m as 2 plus minus root 3. But don't forget, we don't have m from the original question. What we have is tan 15. So let's recall. But tan 15 is equals to m. So anywhere I see m, let's put tan 15. So here becomes tan 15 degrees equals to 2 minus root 3. So we are taking the negative value, not the positive. Because of demand, we use only the negative. So we can see at the end of the day, we have tan 15 as 2 minus root 3. So thank you for watching, and subscribe to the channel.